next speaker is Tim from Venafi. So Tim is the cert-manager maintainer, and his talk is on simplifying multi-cluster identities with cert-manager. So let's have a look at where Tim is. Hello, Tim.
Hey.
Welcome back to KubeCrash.
Yes, another
KubeCrash
alumni, and I mean, I love them all, but one of my favorite presenters. I know we're not supposed to say that. They're all great.
Thank you.
Awesome. Thank you, Tim, and take it away.
Thank you. Yeah, it's great to be back. So in this presentation, I'll be talking about the cert-manager world and how to use cert-manager to manage machine identities in these large-scale multi-cluster environments. So my name is Tim. As explained, I work for Venafi. I'm a senior software engineer there, and Venafi is one of the biggest sponsors of cert-manager. So we have a couple of cert-manager maintainers that work actively on cert-manager. And cert-manager itself is let me try to get to the next slide. It's a project that has multiple sub-projects in it, like cert-manager, trust manager. We have like an approval policy project and CSI driver. And this full suite of products basically have one common theme, and that's X509 certificate management for Kubernetes and OpenShift. And basically, we try to solve everything around that, make sure that when you are using Kubernetes, you don't have to worry about X509 certificate management. cert-manager does it for you. You can just focus on your business logic. The cert-manager project is a CNCF incubating project. We are doing our very best to become like a graduated project. We're actively working on that, but that's still in the pipeline. It's not yet there, but we are really working hard on that. We also are a fairly popular project. Well, it's me who's saying that, but I think I can prove it by telling you about the amount of GitHub stars and contributors and downloads that we have, which I think is fairly impressive. So in this presentation, I'll be going over what machine identities are, how they work, how you manage them at scale, because that's not that easy. And then I'll also explain an example setup, explain how to use cert-manager in combination with emissary and linkerd. Then I'll also go to the cert-manager website and try to explain, using the cert-manager website, how to configure everything around your cert-manager setup. It's like first for me, so let's see how it turns out. And then if we have a bit of time over, I can also go through some additional slides going into some more details about cert-manager approval policy and trust manager. But first, let's start talking about machine identities. How do they work, and what are they used for? So you might recognize this from previous KubeCrash, but I think this is very important to kind of get us on the same level, also try to use the same terms for things so that everyone can also follow along in the rest of the story. I made some minor changes here too, so you have to be very attentive to get the full story. So in this example, I'll be explaining how TLS works, and I'll be doing that from the perspective of someone who's very interested into certificates. So I'll be saying the word certificate a lot. So basically, the idea is you have a laptop and you want to connect to your bank's website. The assumption that I'm making here is that you know that your bank corresponds to the domain name mybank.com. So you want to go to mybank.com, you type that address in your address bar, there is a DNS query that's being sent, and then you get back this IP address, you connect to the IP address, and ultimately you make a request to the web server, right? Then the web server responds to you, and what it will do, it will prove to you that it is actually the owner of the domain name mybank.com. And it does that through a set of certificates that it sends to you. So these certificates are a proof of identity. It proves that the server has the identity of mybank.com. After you receive those certificates and you verify that those certificates are valid, I'll go into more details how you can do that. You basically can trust, okay, this server corresponds to mybank.com. There has been, additional to that, there's some like cryptographic stuff going on. So thanks to the combination of that with the cryptographic stuff, you can rest assured that you're actually talking to mybank.com and not to some kind of imposter or some man in the middle. So the handshake is done, and now you can send your confidential information to the server because you know that this is the server that owns mybank.com. And then the server can also start trusting you after you log in, for example. It trusts whatever you're saying. So in this example, I have made some assumptions. I already explained some of them. So first of all, we are assuming that you know that mybank.com actually corresponds to is the website of your bank. So if you mistype and you say mybanks.com or like my bank without a dash, you might get to another website, and that website will also show up as valid because the identity of that website will also be mybank.com without the dash then. So there's no correlation here between the actual institution, mybank, and mybank.com. So that's something we assume you did correctly. And then also we assume that you have a way to verify that the certificates that you get back from the server are actually valid. And there is another variation on this, and that's called mTLS, which stands for mutual TLS. And basically this means that both parties use a set of certificates to authenticate themselves. So instead of using a username and password for the client then, both parties actually send certificates to each other, and then they can trust each other directly after the handshake is completed. So this is done often when you have like server-to-server communication. Also, maybe if you have like smart card with a certificate on it, you could also do this. But basically, it's the same principle, but now it's two-way identification. And again, here there are some assumptions that are made. So let's now focus on these assumptions, and let's think about what the complexity is. The complexities are that you have to take into account when verifying certificates. So there are two problems that we want to solve, basically. First of all, each application needs this bundle of certificates that prove that the server is who they say they are. So the bundle has to prove that the identity of the server is actually mybank.com. And then each client, so each HTTPS client that connects to the server, has to have a certain set of rules, a framework, a way of verifying that the certificates that are presented to it when it connects to the server are actually valid. So in order to do that, there is a third party, and that's called the certificate authority. And this certificate authority exactly does these two things. So on one side, it provides the server with a set of certificates that prove its identity. And in Kubernetes, you can automate this step where you go from certificate authority to server. The issuance step, you can automate that using cert-manager. Then on the other side, you look at distributing these CA certificates that basically allow you to verify that when you connect to a server, you can trust the identity of that server. And this step is automated in Kubernetes using Trust Manager. And these are, I think, two of the main sub-projects of cert-manager. If we go now into a bit more detail, a bit more concrete in terms of like certificates and so on, you get something that looks like this. So here I'm presenting a certificate chain. And basically, if you think about what a CA is actually a company or an entity that manages this large tree of certificates. And this tree starts at the root with a CA certificate. Then the CA certificate has like a lot of child certificates, which are called intermediate certificates, because these certificates also have other certificates below them, and so on, until you get to the leaf certificates, which actually contain the identities of these servers, so the server that you are trying to connect to. And for one server setup, you actually are only interested in one part in that tree, and that part is called this certificate chain. So on setup, what you do is you take a look at a certificate chain, and you take the CA certificate, and that is trusted by the client. So that has to be put into trust store of all these clients, all these laptops, or all these HTTPS clients that you run in your cluster and that do HTTPS calls, basically. Then the other set of certificates, starting from the intermediate, like the child certificate of CA certificate, right up until and including the server certificates, are actually provisioned to these servers. So that's where cert-manager does that automatically for you. And the server stores the set of certificates. And when you connect to the server, like I explained before, the server sends this bundle of certificates to the client. And now the client can verify the full chain because it has the CA certificate in its store, and it checks that the signature of the first certificate in this chain that is received by the client from the server is actually signed by the CA certificate. And then it also knows, of course, what the identity of the server is. So that's in a lot of detail explains how TLS works. But you might have noticed that there are a lot of certificates here, right? And so that's a challenge, how to manage these machine identities, these certificates at large scale. So I think there are three things that you have to do right in order to do this at large scale. So first of all, you want to automate everything. For that, you can use cert-manager, you can use trust-manager. These two tools are very powerful in the Kubernetes world, and they really do a lot for you. So definitely look into that. If there's one thing you want to take away from this talk, look into cert-manager, look into trust-manager. Second of all, once you have set up automation, you want to make sure that you're monitoring your automation. Because automation is great as long as everything works, but once automation doesn't work, all hell breaks loose and you have a lot of problems. So what you want to make sure of is that your automation works and that you're notified when your automation stops working. And for that, you set up some monitoring, some rules that make sure that you get the right alerts at the right time. So that prevents you from having any outages. Also, monitoring is very useful. I'm not sure if you call it monitoring, but like insights are very useful to also find any kind of misconfigurations, any kind of like misbehavior of anyone who's requesting certificates, any kind of breaches, that kind of stuff. But then I think it's more for the InfoSec team who's interested in that. This slide is mostly tailored towards the platform admin. So platform admin, I think, can think a lot about monitoring in terms of preventing outages. But the third thing that I think not a lot of companies know about or have, I don't think they have like fully moved to this point where they can start thinking about policy. But the third thing is policy, and that is really important when you try to scale things, to do things at large scale. Because ultimately, as a platform admin, what you want to do is you want to automate everything, but you also want to make sure that you yourself are actually not involved anymore when something has to happen. So you want to give each application team the autonomy to request machine identities themselves and to fully set up their own environment without you having to approve things or set things up for them. They actually should be able to do that automatically themselves. So for that, in order to guide them in that, you have to set up some rules, some policies. And these policies can do multiple things. But I think one of the most important things is you want to prevent them from doing any kind of weird stuff, making any kind of mistakes. And so this is what we call approval policies. So basically, when a certificate is requested, you will make an automated approval decision on whether you want to approve or deny the requested certificate. And this approval decision can be made based on the context of the requests. So for example, you say this certificate can only be requested in this namespace. It can only be requested by this for this service account, that kind of stuff. And this is also like an area where we're actively working, and we are actually making more solutions and trying to improve our solutions. So now let's have a look at how to do this automation in a multi-cluster setup. So the team is multi-cluster, but actually, I think for machine identities, this comes very naturally. Ultimately, if you look at a typical multi-cluster setup, what you will have is in each cluster, you'll have your own cert-manager instance, probably also like your trust manager instance, maybe some kind of CSI driver for cert-manager. And all these cert-manager instances, they will all be connected to a centralized certificate authority. That could be like a public certificate authority, like Let's Encrypt, but also for private PKI. You are looking at like a certificate authority like Venafi, like Vault, that contains your, that can issue certificates, machine identities for your private PKI, so that you have one common CA certificate that you can trust, and then you can connect to any kind of cluster in your setup. So this, for example, we'll see this later, but in this example, this will enable you to connect from one cluster, from a Linkerd. Using Linkerd, you can then connect in one cluster from a pod to another pod in another cluster, cross-cluster communication using mTLS, for example, because all machine identities share a common CA certificate. So that's pretty cool, but this comes very natural, I think, when you are using cert-manager, and this is actually part of your PKI setup. So next I'll be explaining through an example how you can set up a cert-manager for requesting emissary certificates, but also I'll explain it for Linkerd certificates. So in this example, I'll be requesting a publicly trusted certificate. So a publicly trusted certificate is a certificate that is issued by a CA that has its roots in the Mozilla publicly trusted trust store. So basically the trust store that's like included in every operating system, but also included in every browser. And we will be requesting a certificate from Let's Encrypt using cert-manager. So cert-manager will automatically issue a certificate for you. It will renew that certificate. And we will configure this so that cert-manager provisions that certificate in a secret resource. And then we'll point emissary to the secret so that it can start using it. Additionally, what we can do is we can use Trust Manager to distribute the trust stores, the publicly trusted certificates, to all our containers in our cluster, so that all these containers can make HTTPS connections to this endpoint, this emissary endpoint, but also to any kind of website that is publicly trusted. So this is an example for emissary, but there's also an example here for Linkerd, where in this case, we are not using publicly trusted certificates. Instead, we are using a private PKI, so private public key infrastructure, which means that the CA certificate, the CA is not part of the Mozilla Trust Store. Instead, it's like a CA that we created in our company and that only all the clients in our companies trust, basically. So an example of where you could get machine identities from that are part of this private PKI setup are HashiCorp Vault and Venafi, for example. And we can then use cert-manager to issue certificates from these CA providers. And in this example, because Linkerd requires this, we will request a CA certificate. And the CA certificate can issue other certificates. So the CA certificate will be requested from Vault or from Venafi through cert-manager, will be put in a secret resource, and then Linkerd is pointed to that secret resource and can issue its own certificates, its own mTLS certificates. Additionally, we point Linkerd to our CA certificate, and Linkerd will provision all the containers with these CA certificates. I think it's called like a trust anchor, Linkerd. And that way you can do cross-cluster pod-to-pod communication using Linkerd, because they all share the same CA certificate and they all have mTLS certificates that are issued through that private PKI. So that's the full explanation of the example setup. And now I'll try to explain by using the website, the cert-manager website, how to set this up for your environment, basically. So I'll just go through the documentation and guide you through this and try to explain everything and how to read the documentation, basically. So first of all, you go to the website, you go to documentation, and then here on the left, you see the 5 steps that you have to take to get to this multi-cluster setup, this at-scale setup. So first of all, what you want to do is you want to install cert-manager. Pretty basic. You look at the Helm instructions. Here in this section, we actually explain how you can configure cert-manager using CLI flags to maybe enable certain feature gates, to enable certain sane defaults. But also, I think a new thing that we added very recently is the option to configure things using config files, which can be provisioned through config maps and are mounted in the different controller containers. So after you've set up cert-manager, you verify that it's working with some simple examples, you get to the next step, and that is to configure an issuer. So in cert-manager, an issuer is basically a description of how to connect to a CA, so to a certificate authority. So there are multiple built-in issuers for cert-manager: self-signed, CA, Vault, Venafi, Acme. And then there are also some external issuers, which are issuers that aren't installed by default when you install cert-manager, but you have to install separately. So for example, AWS KMS has here an issuer built that you have to install separately. For our 2 examples, we talked about Vault and we talked about Acme. So let's take a look at how to configure an issuer for Vault. Well, basically, this is an example. You just create this resource. You configure how to connect to the Vault instance, what the path is, what the server is, like what the CA bundle is, and that kind of stuff. And then the issuer will update its own status, like the cert-manager control will do that, and it will say whether it can connect to Vault or not. And after that, the issuer is configured, and you can start using it. The same is true for Acme, where you create an Acme issuer, you configure what Acme server you want to use. For example, here, the Let's Encrypt server. Here is the staging one. You want to start with staging and then move to production later to not blow any kind of rate limiting stuff. You want to start with staging first. And this is basically the full configuration for an issuer. And then the next step is to start requesting certificates from that issuer. And here there are a lot of options, but the simplest, most common option is to just request a certificate using its certificate resource. So in cert-manager, you have these certificate resources, which look like this. So this is a certificate resource. And in the certificate resource, you specify what you want the certificate to look like, or what you want to request from the CA, basically. So in this example, you want to request a certificate that has this subject in it with organization set to Jetstack, with common name set to example.com. You want it to be a non-CA, for example. But additional to that, to the properties of the certificate, you can also specify what issuer you want to use, right? So the issuer that we just configured, we specify that here. So we say, okay, we want to request a Vault issuer, we request a certificate through a Vault issuer, or we want to request a certificate through an Acme issuer. And that's what you specify there. And lastly, here you specify the target. So that's the location where the issued certificates will live. So cert-manager will create a secret and put the signed certificate in there, together with the private key that it's generated to obtain that certificate. So after you create a certificate resource, cert-manager will detect the creation of that certificate resource, and it will start creating certificate requests. It creates a certificate request first time you create a certificate, but also every time you need to renew the certificate. So it's like auto-renewed, so that you never have an expired certificate. And the certificate request actually contains all the literal information that's sent to DCA. So in this example, it's like an encoded version of the X509 CSR, and some additional information here, like the duration, which is sent separately, but also it contains the issuer reference. And it's very useful to have a look at what certificate requests exist just to debug what's happening. But ultimately, cert-manager will take care of this. And in the ideal case where there is no problem and everything works well, you actually don't have to look at the certificate requests because they are created behind the scenes, actually. But what cert-manager will do is it will create this, and then the issuer controller will actually see that there is a certificate request with a reference that references one of its issuers, and it will send this certificate request to the CA, obtain a signed certificate, and put that signed certificate in the status of this certificate request. After which the certificate controller will then kick back in and take that signed certificate and put it in the secret that we specified here. So, okay, after that, we're done. Cert-manager completed its job. It obtained a signed certificate that corresponds to the private key that was generated also in that secrets resource. So now you just mount the secret in your container and you start using the certificate and the private key in your application and web server, and that is all working fine. So let's go to the next step, and that's about distributing trust. So basically updating all the HTTPS clients in your cluster so that they are up to date with the latest trust store. Maybe when you rotate your private PKI CAs, you want to update all the clients, or maybe when there is like a breach in some of the public CAs, you also want to quickly update all the clients. That's where distributing trust is very important. So for this, we will be using Trust Manager, and Trust Manager reconciles these bundle resources. And bundle resource is actually pretty simple. It's just a description that describes a set of sources. So where do you get the certificates from? And it describes a set of targets. Where do you put the certificates? So the targets are just a bunch of config maps across multiple namespaces. And these will be updated by Trust Manager when the sources are changed or when we update one of these resources. And then the targets will be updated, and the idea is that you take the target and you mount that in a container such that it's mounted in the trust store of the HTTPS clients that runs in that container. And so that's the way you can keep all your HTTPS clients up to date, their trust stores up to date, without having to like rebuild images or go through this whole GitOps pipeline. You can just do that directly at runtime. Makes it much easier to fix problems when they occur because, for example, of any kind of compromise. So that's distributing trust. Lastly, I would like to quickly talk about policies. And policies, I think, is something that we are still actively working on and trying to improve things. But generally, I think we identified 3 different kind of policies. First of all, we have defaulting policies or defaulting rules. Then we have an approval policy, which is approving a request for a machine identity, for a certificate. And lastly, we have issuing policy, and that's more about how to go from X59 CSR to an X59 certificate. So let's start with the defaulting policy. These are a set of rules that you specify, and the goal is to actually simplify the life of your application team such that the application team has to know less about what details they have to provide in all these certificate resources. Instead, you default those details for them. They just say, okay, I want to have a certificate, and it definitely has to have these attributes. But then you default some of the other attributes that you know that you know some same defaults for. So that's basically making the life of the application team easier. Next, the approval policy is making the life of the application team a bit harder, I think. Well, at least it depends on how you look at it, but the goal of an approval policy is basically to approve or deny certain requests. So if the application team requests a certificate and you know that this shouldn't be allowed, maybe like it's an insecure private key that's used, or maybe it's like an incorrect domain name that's requested, you deny the request, and some feedback is given to the application team in terms of like, okay, this doesn't conform to the policy that we have set up. So in a way, it kind of makes the life of the application team harder, but I think in the long term, it will make it easier because there will be no bugs and no problems and no security issues. And then lastly, the issuing policy, that's actually something that is less of a concern to cert-manager because this is fully implemented by the issuer itself. So the issuer fully decides how to map an X59 certificate signing request to an X59 certificate. So any of the properties that it received by when it's received something from the certificate resource, you can actually just ignore these properties. Like if you send a request to Let's Encrypt, I think with SCA equals true, it will just ignore that and it will say, here's a certificate, but it's like not a CA certificate. And that kind of policy, the mapping, the ignoral of certain fields, that kind of stuff, that's all the issuing policy. That's what we call the issuing policy. And that's really up to the issuer itself. But the important thing here is to remind you here that there is no contracts that we guarantee as cert-manager developers. There's no contract between the X59 certificate signing request and a certificate. So you might request one thing and get another thing, and that's totally up to the issuer itself. They can decide that, and they can have their own rules. So you have to go to them and talk with them if you want to have any guarantees about the issuing policy. So that's it for the documentation and explaining everything around that. Not sure how much time I still have left here.
We are running up against time.
Okay.
Also, there was a question for you. I don't know if you saw it in the chat from Johannes. It says, can you recommend certain subreddits for your information gathering?
Well, there are a lot of questions. Oh, okay.
I know. I think you got to most of them, or other people did. And by the way, thank you, community, for answering questions of other people. I love that this has been very conversational in the chat. But one question that I had to pull over from one of the areas that people can't see was from Johannes, and it just said, can you recommend certain subreddits for your information gathering?
So subreddit, does that mean like on Reddit or yes?
On Reddit, yeah.
Okay. Well, I'm not like a super frequent Reddit user, but we are definitely active, very active on Slack. So if you have any experience with Slack, Let me try to not share.
Yeah, you can pitch your Slack channel, and then anyone else who's in the chat, if you know some good subreddit. So Reddit is Reddit, and then a subreddit tends to be like a discussion thread, or a company might have a subreddit. And so it's just something, people gathering around a certain topic. Kubernetes has one. Every company here has one. So yeah, that's just what they mean by subreddit. But yes, if there's any threads or any subreddits that anyone else knows, otherwise, Tim, what is your Slack?
Yes. So if you go to the link that I just pasted in the chat, you will see that we have some Slack channels listed there. The cert-manager channel, which is more for users, and then the cert-manager dev channel, which is also for developers. Additionally, we also have some meetings, Google meetings that happen daily, but also a bi-weekly meeting where we talk more about like general concepts. So these meetings are all open and you can join them when you want. So definitely check out that page that I just linked and try to join us and see. We'll be happy to help you, definitely.
Awesome. Well, Tim, thank you so much. Great presentation for everybody today. There's lots of questions though, like different comments and whatnot. So, I'm sure Tim will stay around. And if you have further questions or whatnot, please ask the question. Thank you, Tim.